So do you see my whimsical here?
Yes, this is perfect.
Perfect.
Yeah,
All
this
right.
is perfect. So the question for today is design a live video system.
All right. I see. So is it something like Facebook Live?
Yeah, let's go with that.
Okay. So a user can stream a video. Seems one of the necessary functional requirements. And the viewer can subscribe to a stream or access or view a stream, subscribe to a stream, and keep receiving the video.
Yeah.
What else is involved? I'm thinking the user can interact like.
Let's just go with this two requirement. Maybe later we can talk about the comment or like something like that. But for now, let's just.
Okay, so we're gonna do something really. How much time do we have?
So what's that? How much time?
Yes.
I think in 40 minutes.
All right.
Yeah.
Perfect.
So right now it's like in the 10:39.
All right.
Yeah.
So let's go with these functional requirements.
Yeah.
I think for this problem, some non-functional requirements are required. As usual, we need a high availability. So in that case, what does that mean? A stream going down is a big problem, right? So I would say the availability we want is probably around 5 to 6 nines.
Okay.
So 5 nines would be around 5 minutes, 6 nines a bit less. We need a really low latency. I think we probably need, in terms of delay, when someone records something, let's say that all users need to have seen the recording after. Would you be fine with 1 to 2 seconds?
Yeah, that's fine.
Okay. So consistency here for the functional requirement you just gave me, the notion of consistency wouldn't have a lot of meaning per se. So I'm not going to talk too much about it because we are writing a video into a system, but you have many readers, viewers viewing it at the same time, unless you see a clear consistency use case. But I don't personally, so I'm not going to mention that for now.
Okay, so you mean it's not a strong consistency system, right? We don't need a strong consistency.
It's not that, is that I cannot imagine, I cannot think of a use case where I can say, hey, this is what I would call consistency. For example, for a bank, consistency would be when I'm making a transaction, a bank transaction, what I put in my bank will always be the same when I view it. No matter where I see it on any devices, for example. But here I don't have a use case to give you because it's literally someone streaming a video to someone else, and there is no, that other person that sees is just a consumer.
Okay.
Right. So do we want to have some notion of replay? Do we want to make it durable? I think
yes, we want to support that so the people can come back later.
Perfect. The read to write ratio here is heavily skewed, I think, towards the reads, probably 10,000 to 1 reads to write. That's my assumption.
Yeah. But yeah, that's fine. That's fine.
Okay.
It's going to be a lot more reads than
yes. Yes. And we want something highly scalable, which means that if we add more streams as a requirement, we want to be able to add a node and be able to scale with no problem, particularly when we have peaks, when people stream more, let's say the new year, for example, if we are on Facebook Live.
Okay.
All right. In terms of capacity estimation, I think it's really important to identify the bandwidth consumption, the queries per second. So more specifically, the number of lives per day, I think would be an important estimation. So how many users do we have on Facebook Live or this system that we are building? How many users per day? Let's say 200 million viewers per day. Does it seem fair?
How about we go by number of live videos per day, and then
okay, so live per day, let's say we have 10,000 lives per day. How does that sound?
yeah, sure.
Maybe more, 100,000. I don't know. It's Facebook Live. I'm not sure.
Yeah, probably 100K probably is better.
And these videos, when we stream them, if we stream them in a decent resolution, so I have a number I remember, which is that roughly a video of 10 seconds is roughly 5 megabytes. But it depends on the encoding that you use, right? And also the compression. So we'll have to talk about that. Let's assume we have 10 seconds and 5 megabytes. This means that 1 second stream, you see, I'm trying to find the number of megabytes per second. So 1 second would be 0.5, and I'm going to use exponential, so E6 bytes. I'm doing this so that, so I multiply this by E5 lives per day. And so how many lives per day? Let's convert those number of lives per day into lives per second. So this is exactly 1 live per second, right? So I'm going to convert it like this, because divided by E5 seconds, we have 100,000 seconds in a day.
Yeah.
Okay, so 0.5 E6 bytes is what remains. And so, well, that's a bit surprising. Yeah, no, that's not, because there is another parameter that's missing here. Is the number of viewers per live on average.
Yeah, that's good good number to estimate, I think.
Yeah. So what would it be? Let's say one live on average has 100 people watching. So it's on average. So you could be, we need a number, which is the number of the highest live we could have. I remember the wedding, the UK wedding, or even the cricket in India. I think it's something like 100 millions. That's the order of magnitude. But that's the max.
Yeah,
we could have. And for us, let's say we have 100 per on average, or 1,000. Does it seem fair? Okay, let's go for with 1,000. So E3. Now let me do 0.5 E6 E3. So it's E9 0.5. That doesn't seem a lot. I'm a bit surprised. That's 500 gigabytes per second. So probably something is wrong here. So I did 1 second, 100,000 lives per day, E5 lives, E5 seconds. Number of viewers per live on average is E3. Okay. Yeah, it looks like it's 500 gigabytes per second. What do you think about that?
I thought that's decent number.
Okay. So, so what do we do about that? Is we see it's high, and what else could we think of? If we persist this data, this means that we have this number here, 0.5 E6 bytes per second, that is being stored every second. So 0.5 E6 bytes stored per second. And do you want me to convert this into gigabytes, or we can move on? So that's probably also a big amount that we'll have to store somewhere to achieve durability.
Right. I think with the 500 gigabyte per second streaming, we probably have need to have a lot of storage. I mean, we already know that. I don't think we need to calculate that. How about calculating? I think we need to calculate how much reads per second.
Yeah, how many reads per second? So if we have 1,000 people per live and 1 live per second. Wait, is it the right way to think about that? I think it's simpler if you tell me the number of users, because if you have, even if you have, let's say 1,000 people per live, yeah, that would be, okay, I think we can get it. So that's E8 plus E3 times E3. And this is the number of people watching per day.
Yeah.
Lives times E3 watchers equals E11 viewers. That seems way too much per day. You see, because, yeah, I think we need the number of users here because we cannot extrapolate just from the number of people watching a live and the number of lives per day. So I'm going to assume on Facebook we have on average 300 million users. You see,
I don't know. So now we are talking about number of reads per second as number of reads, right? RPS, right?
Yeah.
We're not talking about number of users, unique users.
Yeah, but that's how I'm going to extrapolate. It's based on the number of users. Let's say they're watching this live, so they're fetching data probably every second or less, right? So that's one query. So I need to have this number of users. If I have 300 million users, and I'm assuming that they watch a live on average 1 hour per day, which is a lot. This means, how do I convert that? Based on the number of users times the hours per day. So the goal is to get the number of queries per second. Yeah, that would be 300 million users times 1 hour per day. This number we have to divide it by 24 to have because these are the number of users per day. If we divide it by 24, this will give us the number of watchers per hour. Yeah, I'm getting confused here. I think I'm taking way too much time, and I'm not sure that for everyone here. So it's probably a big amount of queries per second. But I'm getting confused by this live. I will need to estimate also the number of queries you do when you are streaming, when you are receiving a stream, a video stream. So I'd say that's a big amount. I'm going to come back to it if I have time.
Yeah, that's fine. From that number we know it's like it's going to be a lot. So let's move to other part of.
All right. Yeah. So API design. So I think when someone starts streaming a video, what would be nice is to create a stream, and the user needs to be authenticated. When he creates a stream, he can probably give it a title, and he will receive an acknowledgement, and ideally also a stream ID. But that's not all. When you create a stream, that's just one part. you need to upload and actually stream. So when you start creating your stream, immediately after that, a WebSocket connection or something else, will define what that is, will be initiated so that you can start encoding your video. I'm going to assume this API request is also handling that part. Okay, so let's say the user has a simple API, which is create stream. And once it's happened, that's it, he's actually streaming. Another user, there's something we did not talk about, but you need to follow someone to receive his stream, or how do we access the stream? We are on the news feed and we could visualize it. How does that work?
So if someone stream, it's gonna show up somebody's app and other people's app, right? So they, if they stay on it, then that means you're streaming to that video to that user, right?
Okay, I see. So there will be get visualize stream.
Mm-hmm.
You probably need a user token, and I think that's it too.
Mm-hmm.
So you receive an acknowledgement and your video is being streamed. So I would say acknowledgement here. So that's pretty light, I think, in design, but let me think of something else. So these are the user-facing APIs, I think.
Mm-hmm.
So let's talk about, I could talk about the database, but here it's literally a video. We will need to also handle subscriptions, because those people that visualize the stream, they will subscribe to a table so that we know that we should stream the video to them. So let's say I have a streamer and he hits our API gateway, the Facebook API gateway. And one of the servers being hit is the streaming server, streaming service. The streaming service initiates a stream and writes it into a database synchronously. This database has the list of all the streams actually happening right now.
Mm-hmm.
I'm thinking that creating a stream is nice, but probably there is another API which involved send data or stream.
Yeah.
It makes sense to me, because it's not enough to create the stream. I think it would involve a video, so an encoded video. You have to actually send it. Upload stream, is another way to call this API.
So what's that video? What's the second parameter?
Yeah, it's a binary.
Binary, it's the entire video?
No, not the entire video. It's the streamed binary. It's a it's a packet of the video you're currently streaming.
Okay.
Here we're constantly receiving an acknowledgement from the servers,
Yeah.
So this create stream service would be initiated, would be called, but then I'm creating another service just for the streaming part. And so here it's important to notice that our data is transient. Obviously we want to persist it, but by nature it is transient. We want to send it to someone, and we don't necessarily care about losing data. Obviously, that's a problem to lose data, but if we do lose the data, no matter what, the user will be impacted because they are watching live, right? So I'm thinking of using a UDP connection and points of presence, POP servers, to stream the data to watchers. So let me talk about those watchers. A watcher send an HTTP request to watch service, initiate stream, watch stream service. For now, it's just an HTTP request to say, hey, I would like to watch this stream. When this happens, the watch stream service will give to this watcher, will connect it to a front-end server. This front-end server is only sending data to the watcher. So I'm recommending server sent, the server sent event, long polling server sent event. And the way this is going to work is the watcher is going to send a request to this front-end server. And with only this connection, the front-end server will constantly send data to the watcher. I'm not using a WebSocket connection because I don't need to send the watcher doesn't send data to the front-end server. And even if we had interactions like, for example, like and comments, I would not use this either because it's probably handled by another API. So now let's talk about this front-end server. Let's reverse engineer. This front-end server has my data, right? The data that was here. How did it happen? I'm suggesting the structure in points of presence where when a streamer sends his data, let's say I'm in the US and someone is watching in Japan, this upload stream service will send data synchronously, and we'll talk about how we achieve durability after, synchronously to a point of presence. So what this is in a data center, something optimized to only send data, has a lot of memory, and it's basically built to send data and serve data to users. So this upload stream service will upload data to this point of presence in the US, and it will be redistributed to everyone in the world. How do we achieve that? How do we know where users are currently subscribed to the stream? The watch stream service will help us do that. So the watch stream service will write data into. So I'm talking a lot. So do you have any feedback so far about what I'm building?
No, I'd like you to finish the design a little bit more. So I probably gonna ask you a question after that.
I see. Yeah. So this data store will so the subscription data store, it is used to know where to send the data when a stream is initiated. So when I create my stream, not only do I need to write this stream in the database, but I also need to fetch the the people that are currently watching, and it's a live information. So it has to be constantly streamed, this information, this subscription information, close to the service that actually sends the data, so that we know where to send geographically or stream, because we don't want to send it in Australia if nobody is watching in Australia. Based on that, this POP server, which is regional, let's say in New York, will replicate the data to other servers in other regions. One of these regions will be Asia, or even Asia East. And Asia East will serve some of these front-end servers. So this is cached. The video is cached in memory, and these front-end servers hit the cache, which makes the video read fast. And so far, this is the components I would like to use for my for the design.
Okay, so this is roughly high level design, right? So anything you want to add, or we can talk about detail?
We can talk about details.
Okay.
You can tell me, for example, how we handle subscriptions. Or
yeah, so let's talk about. Well, first, let's just so I understand your design, right? So now let's walk through the streamer start to create a stream, and stream the video, and then watcher gonna get that video. Just walk me through the entire process.
yes, the streamer creates a stream, and it's synchronized into the stream database. Only the metadata is synchronized there. The upload stream service will constantly stream the data into a POP server. This POP server will propagate the information to every region. One of these regions will be the front-end server of the watcher, but let's stop here. So far, we don't have any watcher because we initiated the stream. So we need to somehow inform, maybe in our newsfeed or some other place. I'm not going to cover this in our design, but in Facebook newsfeed, there needs to be people that need to be aware that the stream started. Let's assume that somehow they managed to view this the stream. It's going to initiate. So they're scrolling and hop, they just find this live. It's going to initiate an HTTP request into the watch stream service. This watch stream service will help the watcher connect to the appropriate front-end servers that has the video.
Okay, I'm not so clear about what does the watch stream service do?
Yes, once someone watches, he's going to populate the subscriptions data store, which is used by the upload stream service to know where to fetch, where to send this data. So what I'm thinking is, when you send a video, you also send metadata on what are the availability zones this video should be sent to. This way, the POP server here, which is just a server dedicated to transmitting data, to transmit data, this POP server can know which region should be sent. It should be sent to, right? Because you don't want to send to regions where nobody's watching. So that's the goal of the watch stream service. It's to write into the subscriptions data store.
Okay. Yeah, that makes sense to me.
We can dive deeper into anything you want, though. Scalability, how do we show this, the database design of this subscription data store. Just
Okay, so now I still know that not clear about the process. So now let's say I start to stream a video, right?
Yes.
How other people gonna see my video? It's like
Yeah, well, you need some kind of platform, right? You
okay,
do it
okay.
from
So
the
let's say
newsfeed.
let's say other users see my video post, right? Which is a
Yes.
live, and then it's gonna make call to the watch stream service, right? And then
Yes.
saying I'm subscribing this video, and then from there, and then how the upload stream service is gonna know I subscribed?
So that's a good point. Right now, the upload streaming, you see this arrow, it's actually pulling from the subscription store. That's stupid because we don't want to constantly polling these subscription stores to see if something is new.
Right.
This makes me think that this design is not the best. Let's introduce asynchronicity with a queue. We still need this data store, but the watch stream service synchronously, when the user watches, is going to synchronously write into a queue and give an acknowledgement when it's written to the queue. This queue will be consumed by subscription consumer whose goal is to write it into the subscription data store. And so let me think about that. How do we inform the upload stream service that now, let's say Japan is one of the regions for which the stream needs to be sent? Let me think about that. How do we inform this upload stream service? Also, I'm also thinking about something. This POP server here, I'm not sure it's really useful. Ideally, here I'm in a data center, okay? I'm fetching my data into a data center, let's say North Virginia, and I want to send it to another point of presence. Sorry for the noise. Another point of presence. I guess I don't really need a POP server. This upload stream service, I think, already can do the job on its own, right? So that was a bit, I think, confusing. But yes, this is mandatory. We need somehow to send it to other regions, and one of these regions is Asia. So I was just thinking about that. Let's correct that. So one of the regions is Asia.
Yeah, but then if you have 10 regions, and then the upload stream service needs to send to the video.
Yes, that's not optimal if you send to 10 regions, because then
Right.
you have to basically, what did we say? 0.5 megabytes per second, 10 times 0.5 megabytes per second, times also all the lives that this single service has to handle. By the way, it's a fleet, but it's multiple nodes, but so that's a problem. The thing though is when you send to a region, you don't need to send it to 10. You can have a tree-based structure like CDN are built. CDNs they are trees. You send data to a node, to let's say 3 nodes, and they can propagate themselves. And this helps with the bandwidth. So
okay,
that's how I would do it. One node sends to, let's say, 3 or 4 nodes, and those 4 nodes can send to other nodes, etc., etc. That optimizes bandwidth.
Okay, so in this design, actual video data is stored in each region, and then video metadata is stored in a stream database.
Video metadata is stored in the stream database. Yeah. Let me think about that though, because this stream database right now is never hit by my watcher. You see, that's a problem. Like I want what are the metadata I'm looking for? I'm looking for the title. What else? If I had some likes, but I don't, but if I had some likes, the watcher would need to see them. And right now, here's what I'm thinking. This is completely separate from the streaming problem. If I want to get the title of a stream, all I have to do is just make an API request, a simple API request, and get the the stream metadata information. It can even be given by the watch stream service, you see? So now the watch stream service not only says, hey, there's a new subscription consumer, but he also gives back the title of the video to the watcher. And to be even more precise, if this watcher comes from the newsfeed of Facebook, he would already have had the title, right? Because it's generated in the newsfeed. We can integrate the newsfeed in this design if you want, but maybe we won't have the time.
Yeah, but I still see there's disconnection between the stream database
let me-
probably have some
let me
kind of
just add.
stream ID, right?
Yeah, well, it depends on where the watcher initiates the stream. I think here that's a big unknown of our design. It's how does the watcher find the stream? And
yeah, let's say the streamer has a stream ID. Okay, so we have a stream ID for each stream, right? And
Yes.
then the watcher got that stream ID somehow, and then from there, how the front end server knows which stream ID. I try to figure out, the watcher, how the front end server know which stream ID I need to send a video for.
So how does the front end server know
Yeah.
for which stream ID?
Which stream I need to set to the watcher.
Okay. So when the watch stream service initiates a connection with the watcher is also sending the stream ID here to this front end server. And this front end server is not only streaming the video for this watcher, he's also streaming other videos. And he has a table in memory. And let me think about that. Yes. He has a table on his memory. He knows which video to send.
Yeah, but remember the region also, the data in each region is just those binary data, right?
Yeah, but it has to have some metadata with it. You send the binary with also the stream ID. So, and also the regions you want to propagate to. I think that's what I was talking about before. I don't see how this design would work if you don't mention with the binary, you also mention the region you need to propagate to somehow.
Okay, let's talk about that, right? So now each region, what's the data structure for each region? What kind of data you're going to store in each region?
So it's transient and it's a binary, and I'm thinking of an in-memory data. There is no structured data here. It's just a binary that is being sent and transmitted.
Where the stream ID is where
integrated, I guess integrated into the, not necessarily into the binary, but it can be added. So you send a binary plus a text. I'm thinking of what would be the best format. But also I'm thinking, do we really need this stream ID? I'm thinking about that also. Do we really need it? All we need to know is that this stream needs to go to this front-end server, right? This binary needs to go to the front-end server.
Without a stream ID, you don't know, right?
Yeah. So I guess I would package it with the binary. And let me think of how to do that. So yes, you can send. Probably you can encode your binary to have the stream ID if you define how the data is stored in your binary. It would be some encoding. So you encode, you have your binary, and in the end or at the beginning, you have the stream ID.
Yeah, but I see the problems on when watcher comes, just start to watch a stream, right? I need to find the current whatever you call it, a stream binary data, which is video data for that stream ID, right?
Yeah, and if he's new on his territory, like if AGIS is the first streamer, we will have to inform this upload stream service that now he has to send the stream to other regions. And how do we achieve that? Let me finish my subscription consumer here. The subscription consumer, I think, somehow needs to think about that. This is the, I think this is a stateful server, right? And although it's sending transient data, it has to, I feel like it has to be stateful, because this way he can know in real time who to send the data to. But I'm honestly, I'm not sure. I'm not familiar with live streaming.
Okay, yeah, that's fine. So we probably have 2 or 3 minutes. Anything you want to add to the design? Anything you want to talk about is the design?
Yeah, well, durability is missing. And so right now, all of my data is in memory. And the idea is that if it's lost, well, no matter what, if it's lost, it will impact the user. So making it persistent won't help us anyway, because it's happening live. So even if the data is lost, it's already a bad experience for the user. Making it persistent won't help us. So making it in memory at least increase the speed at which the data can be sent. But you could imagine that this upload stream service also persists the data, or even better, we would tag the streamer on persisting the data. So instead of this upload stream service persisting it, you could imagine that this streamer sends with a TCP protocol this time, not UDP, send data and uploads, really upload for this time to a video uploader service. And then we can do encoding and make the video nice so that the replay looks really nice, although there could have been some bad quality and some disturbance during the stream. So that's what I'm thinking of. So in this design, the trade-off is that now the streamer is in real time both streaming to, I mean, it's taxing for his bandwidth. But at least our upload stream service doesn't have to store it, because here there is one streamer, but imagine for all the streamers storing this for this little upload stream service. I think we need to separate concerns here and have it durable on another service.
Yeah, makes sense.
To be honest, I'm not sure it makes sense. To me, it seems correct, but I would love to also have the feedback of other people on that.
Yeah. What do you say about anything you want to say about the scalability? Yeah,
so this subscription data store, is a whole topic we did not cover, which is the what is the database used for subscriptions, and how does it propagate to other users, and also this front-end service, how does it know which watcher exactly? I'm thinking of probably using Akka, so having an Akka actor here, where each Akka actor is a watcher, and I know, and every time I have some data coming, I need to identify to which Akka actors I need to send the data. So that's what's missing for scalability, and the sharding here on the subscription data store probably makes sense to shard on the streamer ID, underscore ID. But the problem would be obviously hot partitions. Hot partitions on the streamer ID can be solved by adding more replicas. And I think also sub-sharding if really this streamer is famous. So distributed side, having a composite key.
Yeah. So this architecture, the way the watcher gets video is you do push, right?
Here?
I mean, like the front-end servers. Well, you from in each region, you have server push the video to front-end server, right? And then the watcher gonna get that video from the front-end server.
Yes, it's a push based on the information that we have someone in Japan as that requires it for this specific front-end server. But I don't know exactly here. They had some. I was not sure exactly how we know to which region to propagate. Is it in the video file? Is it in the binary that we know, or I'm not exactly sure how to propagate geographically. But maybe I made the problem way too hard for me because I immediately started from US to Japan. But it's not. It can happen, obviously, right? So.
Yeah. Cool. I think we did it for a little bit over 40 minutes.
Sorry about that.
Yeah. So no, that's fine. I mean, and we probably can stop right here, and then I think everybody else can look at ask you questions, give you feedbacks. I need to think about what kind of feedback I want to give it to you. Let me see.
Yeah. So actually, like, can you pull up the design again?
Yeah, let's talk about it.
Yeah, I have a few questions.
Yeah, I would love to have questions. So.
Yeah, I actually have 3 things that I'd like to clarify about the design. The first is, so you mentioned there is stream database, right? And so once there is a stream that is uploaded, it's actually not a stream, it's an incoming array of bytes because it is just being created. How would you actually convert it into a form that is consumable by the consumer, right? People could be using different mobile formats. Sometimes you cannot have a single mobile format or single video format that everybody can use. And some formats may be optimized for viewing in some surfaces, while other formats may be optimized for viewing in different surfaces, right? How do that conversion here? I don't see any conversion. You just said it's binary.
Yeah, that's true. So it's tricky. Let me put an emphasis on the problem is that there are so many encoding. So how do we know if the work we're going to do is going to be useful? Like, let's say we do the encoding here.
So in this design, where do you do the encoding?
Let's say we do it here. That would be a problem because how do we know then where to send the data for exactly the user that needs this specific encoding? But okay, let's assume we do the naive solution, which would be we do the encoding here for every possible format, and we send it to every possible regions, but we limit only to the regions where people have subscribed. Okay. The problem with this design is that there could be some useless work that is being done because maybe at some regions this encoding is not required. Here I'm imagining the use of Facebook Live when you have only 50 watchers or 100 watchers. Like, it's probably not happening for 100,000. Probably everyone will need the encoding everywhere in every region. But so I'm thinking of putting it in the end. What if instead we always send the same type of data to limit the bandwidth consumption, and then only in the end we do the encoding. So either at the front-end server or even I'm thinking at the web client. What would you think about that?
I don't think that would work, right? Like, encoding is a CPU intensive process. You cannot do it on the front end or in the web client because it's a really CPU intensive process. One thing that you can do is to actually just like encode it in every format, or maybe in have like a list of encoding servers that would auto scale up. So I didn't see the encoding stuff here. So that's one of the questions that I had. So following up with that, right? How would you handle, let's say there is this binary stream coming in, right? And all of a sudden the video goes viral. How would this stack scale? The viral nature of videos is something that most live stream companies handle, and that's one of the core challenges in any live streaming system. Let's say it just starts with one user, and all of a sudden some celebrity, let's say someone who's a sports celebrity, just tweets that to their followers, and all of a sudden everybody starts jumping in, and in a minute or so there is an exponential increase in the number of users watching that stream. How will this architecture scale? What are the components that would need to scale here, and how would you scale it essentially? Like, can you walk me through how things would scale here?
Yes, so these front-end servers, we will need to have multiple of them and store in the subscription data stores or somewhere, which I did not read in my design, somewhere where what is the front-end server where a specific user is watching. So that's one part, this front-end server that needs to scale. The upload stream service, if it's for a stream that is highly viral, it might be too risky to have it handled by one node, because right now what I'm doing is you have one node that streams the data to other regions, and then I'm doing it almost like a peer-to-peer protocol, but directed, obviously, where I'm going to regions using multiple nodes. Here, what I would do if I have a stream that is viral, is probably I would, let's say I'm in the data center of North Virginia. Instead of immediately sending to another region, I could send it to 3 other upload stream service. This way I have more bandwidth, right? Because one node send it to the other region, it's a lot of work for him. What if he had also 3 other nodes? So he's going to send his packet to 3 other nodes, and those 3 other nodes will send it to the other regions. So this upload streaming service, I'm thinking. The subscription data store, now we have much more subscriptions, and they are written into really frequently. So these consumers have to scale to write into the database, and this database also have to scale by the. So here's the thing: I sharded by streamer ID, right? So that's a problem if a video is viral, because the same partition is hit multiple times. So in that case, the number of replicas can change, and there are actually some options to change the number of replicas for a given shard dynamically.
Yeah, yeah, even then, right? So, so I'm a bit surprised you did not use any CDN here, given that this data is immutable. Why not use a CDN?
Yeah, well, the keywords, when I say point of presence, I could have said, I guess it's risky to not mention all the keywords, so let me precise them. You have point of presence, rack server, POP server, which is point of presence, CDN. For me, when I say that, I mention the same thing. These are servers that are optimized for communicating data. They have a structure in trees, and you send data to one, and then it's
so a POP server. Yeah. So a POP server is totally different from a CDN, right? CDN is something that sits in ISP's sites, trying to stream out viral content and viral photos and viral binary blobs, right? Whereas by POP, you mean something that is sitting on a network that is the company's network. While you can actually like have company servers sit in ISPs, acknowledging that these are 2 different things is something that you probably need to mention. And given that CDNs help in viral cases, right? Instead of hitting POPs, it would essentially hit CDNs. The traffic would essentially hit CDNs. So that's something, that's strategy that you could use, and I've seen that being used by a lot of live stream systems, just to stream chunks of videos, or like just push chunks of videos of viral video streams into CDNs and then just let people connect directly from CDNs.
So you want people to connect directly from CDNs, but
yeah. So essentially,
what's the difference? I mean, I'm curious then. What's the difference between the CDN and the front-end server? Do you have a connection here?
A front-end server is something that you use, and that is hosted in your own data center, right? And typically, companies like Facebook and Google have data centers in the number of like lower 2 digits to higher 2 digits, right? I mean, like even higher 2 digits is not possible. So when you say front-end server, that's something that actually sits in a data center, and you can actually have only so many number of data centers where front-end servers could be there. Whereas CDNs, companies like Akamai or Akamai, right, is the most famous CDN here. They have servers out in the wild, literally in thousands of locations. And those would just prevent, particularly for static content, CDNs would just prevent traffic getting into your front-end server, which is probably like in tens or 15s, instead of actually like, so at least for static content, CDN is the way to go. I'm not sure why you feel a front-end server is required here. And if
so do we use front-end server in this design then, and do we how do we connect the CDN with the?
So there are two things, right? One is the metadata, then there is the video itself, right? So typically, if you go look at real world systems, they have metadata that actually just lists the CDN chunks that any watcher needs to go download. And the chunks itself are actually downloaded from the CDN because it's faster to fetch from CDN. The metadata information is getting updated often. So the metadata information is what you actually get from the front-end server. And that can be fetched like once in 10 minutes or 20 minutes.
I don't know. You're saying the front-end server is sending metadata?
Metadata on what chunks are present, what chunks and where to fetch the video from. And the video itself, for viral videos I'm talking about, the video itself is actually, the video chunk itself comes from CDNs. You can go look at like real world architectures. So that's typically how it is. The chunk itself, I mean, like there is no single binary blob, as you mentioned. The videos are actually split into chunks. Each chunk is hosted on a CDN. And the front-end server just has the metadata on where to go fetch it. And because CDNs are actually spread throughout the world, you can just like reduce the amount of traffic coming to our front-end servers. That's typically how it is done for viral videos. And you can essentially use the same front-end server for if the streamer has only like 10 viewers or 15 viewers, right, then your front-end server can very well handle it. And then you can have your own video server in a data center handle it. Yeah, I'm actually taking a lot of time, but there are some flaws in the current design as I see it.
Yeah, I see.
Yeah, I'll open this up to other folks for asking more questions. I took more time than expected.
One question I have is that we also need to consider the bandwidth of the consumers. So different consumers or watchers can be using different internet speed, right? So we also need to tweak the video resolution so that the consumers who have like very high internet bandwidth, they can consume the video in high resolution, and the consumers who have low bandwidth like 2G, they can watch in some low resolution video. So this can improve the user experience.
Yeah, I see. And then I have a question. In that case, do you think it would be interesting to have here, when you send the chunk, the front-end server needs to be aware of the bandwidth quality of the user, or he's sending the chunks of every single resolution?
I think that is something that can be updated like every 10 minutes or so. The watcher can send the update of the internet bandwidth to the front-end server, and I think accordingly, the video resolution can be delivered to the watcher. So I think here we also, while encoding, we need to encode the video in different formats and also take care of different resolutions.
Yeah, I see. So because of the live character of Facebook Live, I was a bit hesitant to use the common methods for that I know, for example, YouTube uses, because it would take, I think it would have taken a lot of time, and for the latency, which was expected to be 1 to 2 seconds, I wonder if it was enough. So I would love to have some feedback about what you think about video encoding and latency. Can they work together, or to which extent? Can we do everything, every single type of processing that we do on YouTube for Facebook Live? I
think one thing that we did not discuss, or maybe I have missed, is that we can have like a few encoding servers, and the encoding in different resolutions and different formats can be done in parallel, right? Okay, can be done in parallel, but doesn't it affect latency? No, I'm worried about latency for that. Now, I'm not saying we should have a garbage resolution, but maybe we should deal with the resolution that is being sent by the streamer, and he should actually be careful about what he sends. And we do limited amount of encoding.
So the interesting times are dropping, and maybe I can provide some feedback. So I think the start from requirement, I think you did a good on the requirement estimation, even for the non-functional requirement. One thing you touched upon on the consistency, I thought it is worth to mention like eventual consistency, right? Eventual consistency in this case, for me personally, I feel like I think it's like different users watch the same video, they could say how to say, one user could have a little bit of delay than the other user. So that's kind of that's kind of eventual consistency from a user perspective. So I think the concept still applies.
Oh, interesting. Okay.
Yeah. They are the in terms of the design, I kind of agree with Zen said. Well, let me talk about the high level first. So I think the overall, I think the right path, I feel like that's working. Read path is I don't know. I don't know if it's gonna scale. So I think the people who watch the video ideally should pull the server, pull the video, not through push. If think about it, if you pull the video from the CDN, then we do not need to keep track of this subscription at all, right? We do not need to do that at all. If the user from a region that region does not have video content, that video content is gonna just reach to the data center and get that content, right? Video content. So I feel like the watcher to pull the video, it's effective design, and also it's very simple. Sometimes we want to design system that's just go with the simple, right? Okay, so the other thing is like the people sometimes we argue like the pull versus the push, right? Sometimes we think the push is more effective. In those cases, probably it's because we do not know if there's new data or not. In this case, we are streaming you know there's gonna have new data, right, coming. And that's why the polling it's more effective also, right?
I see.
Yeah. And also, like I said, the fundamentally make your system a lot more clear, a lot more simple, right? The other feedback is that when you talk about this design, I would think you want first you want to talk about the write pass first, and then you can talk about read pass second. When you talk about the write pass and the read pass, you want to clearly separate the video stream metadata versus the just a stream, binary stream video data. I think those are two you got two types of data, right? For this, I often think about like you design Dropbox or Google Drive. This kind of system will always have two types of data. One is metadata, one is actually binary data chunks, like breakdown into chunks. What else? I know you talk about all these regions. When I hear you talk about regions, I kind of know you probably met CDN kind of architecture. You're talking about that also, but that you use the term front end server also really confused me. And then later I realized front end server probably you were talking about the CDN also, but I was not so sure. But that term also confused me a little bit.
No, but I think I was clearly wrong because I had a push model here, and if
right, okay.
If it is known that a push model is not working for Facebook Live, that's fine. It's just that I had read that this was what was being done for the like interactions. When you like, I've seen that it was a push model. Now having a push model for videos maybe is not so smart, and maybe it's better to have a pull model.
Okay, that makes sense to me.
So, yeah,
it's like even like live comment or like the live reaction can push is more efficient because you do not know whether there's new data or not.
Yeah.
Right? But in this case, somebody is streaming, that data is keep coming. Every poll is not going to be wasted.
I see.
Yeah.
So I would have other questions, but I think we don't have much time. There is one question about CDN and how sparsely it's used, because you use a CDN, let's say you have only one watcher somewhere in Australia, and you're going to use the resource of a CDN just for that. It feels too much. You see?
Yeah, basically your question is like, if I want to cache something, but there's only one user, why bother, right?
Yeah.
That's a good question. I don't know what's the answer, but then hopefully if you build like live radio system, that kind of cases probably is very, very rare, maybe.
Facebook Live, I know I have a lot of friends when they do live, there is only 24 people. So yeah, this is why what made me think about the push model is for the 24 people, it seems pretty efficient in terms of memory used.
Right. Yeah. If a small number of users, I think this your device should work. But even that, if you use a poll, right? If 24 users, the data you're storing in the CDN might be just for the short period of time, right? So, but you still use CDN to guarantee low latency, right? Normally network connection between the CDN and your data center probably is a little bit reliable and faster. And you do not want a user go to the data center for video, those kind of content, right? Because the latency, it's lots of data, and latency could become very bad.
I see.
Yeah. Yeah, I think that's all my comment. Yeah. Anybody else have any comments, questions?
I like both the approaches, like going to the CDN or asking the client to come to the POP servers. But here we are talking about a Facebook system, right? Which is not like something like a paid content or so. So a trade-off in terms of a cost is better to go to the POP servers, right? I mean, if we are like some WebEx or some kind of a system where people are paying us for what you say for latency, and we need something very fast, then cost-wise is definitely goes to the CDN. I mean, considering the cost factor I'm talking about, right?
Oh, yeah, that's actually a good point. Good point. Because usually POP servers, POP infrastructure is owned by the company, right? The CDN is you have to pay, and then if the data stored in the CDN not going to be accessed by a lot of people, and basically cost might be way more than benefit, right? So that's what you're saying, right?
Yes, correct.
Okay, cool. That makes sense to me. That makes sense to me. Yeah, that's a good point. Yeah. That's awesome point.
Yeah. So one thing I feel is there is no one size fits all solution here. So it needs to be figured out from experiment that when CDNs would actually be more beneficial than going to the POP servers. So at what point, like whether it's 100 users or whether it's a million users, at what point do the CDNs become more cost effective? Obviously, the CDNs become more cost effective at a higher cardinality, like a million users or so, because streaming from POP servers also takes a lot of resources, and there might be latency issues as well because the data centers are not close to people. So it needs to be determined when CDNs become cost effective, and that's, I think, an experimentation. That depends on experimentation, but we cannot just have a single solution, be it CDN or POP, for this system.
Yeah. So what you're saying is okay. So now we do the experiment and find out what's that and what's the parameter we want to use to, okay, for this kind of video we're going to use POP, and for the other kind of video we use CDN. Maybe for the very popular video we use CDN. Yeah. Okay.
It's really interesting because in some ways this problem is really extensible to Twitter, where you have the celebrities where you pull and the non-celebrities where you push. Obviously, there are a lot of differences, but it made me think. I went immediately to the push option without mentioning the fact that for really high stream and for streams that are really famous, maybe the CDN is better. And I could have mentioned that an hybrid option is probably what Facebook Live does. Does anyone know?
I think I read the paper or video I watched, the paper I read, they only mention the use of POP, and for the images they use CDN. I think that's how I read it, but I don't know. Those papers probably a little bit old also. I don't know what they're doing right now.
All right. Well, thanks a lot.
Yeah. Cool. Nice discussion today.
Yeah. Does anyone have any other questions, or we can end here? Yeah. Cool. Yeah. Looks like there's any questions. Thank you. Thanks a lot for